mode of conference happening. Right, we welcome you for this international conference over here. So yeah, we will quickly go ahead and start. Right now we have a physical conference happening, and participants will be sharing the presentation from here, and you'll be able to listen to them. And post that, you will be at last of all the presentation, we will give you the opportunity to present. Thank you. Yeah, please.
Good morning to one and all present here. I am Crystal D'Souza from the Department of Computer Science Engineering at CS University. So on behalf of my team, I'll introduce my teammates. This is Andre Roy. I'm Korean and Ashwin Rodriguez. So I will be presenting our paper, Speech Emotion Recognition through Federated Learning for Quality Assurance in Call Centers, here at the IEEE Forum Conference. So our research paper mainly revolves around two concepts, which is speech emotion recognition and federated learning. So as you all know, emotion recognition has a wide range of applications in various domains. But when you talk about call center environment, emotion recognition can mainly help in avoiding customer abuse, for enhancing customer satisfaction, matching your customers to your agents, and so on. Now coming to federated learning. So federated learning is a simple decentralized machine learning technique, which basically enables you to train models locally at multiple sites, where you only deal with the data of that local site. So there is no exchange of data, thereby enhancing and preserving the privacy and security of data. So the goal of federated learning is to basically create a global model by aggregating the updates of these local models so that the global model will have a much higher accuracy, and at the same time, the data is not centralized and you're preserving the privacy. So coming to the problem statement. So as we all know, call centers make a lot of calls on a daily basis. But it's important to ensure that these calls are of high quality and customer satisfaction is also maintained. So in today's scenario, how call center managers basically evaluate the agents is like this. So each agent will have a target number of calls to be achieved every day. So what the agent does is he manually updates these achieved values and reports to the manager. And at the same time, there are also quality assurance analysts who are employed to monitor these calls and provide the operator with feedback. But the thing is, this entire process is very expensive, tedious, and prone to error. But on the other hand, if we consider the emotions of the customer and the agents, then speech emotion recognition can actually automate this whole quality assurance process. Yeah, but building such a system requires a large amount of labeled data. So that brings forward three main issues, which is storage concerns, privacy concerns, and speech emotion, continuous speech emotion recognition.
Your battery. So your battery is low. Good.
Yeah. So moving on. So for our research, we are mainly targeting four emotions, which is happy, angry, neutral, and confused. The reason being that these emotions are most relevant and crucial when it comes to call center environment. So now for our study, we worked with call recordings obtained from a local call center in Kerala. So we had a total of 61 recordings, which was split into 166 segments and divided among 3 processes. So these segments were manually labeled by us, and then we got it validated by the manager of the call center. So moving on to the architecture. So what happens is there's a dashboard that we created. So the manager uploads the call recordings for a specific agent onto the dashboard. Then a speaker diarization algorithm identifies and separates the speakers and then splits it into segments based on each speaker's utterances. So these diarized segments consist of the speaker, the transcription of the segment, as well as the start time and end time. So this data is stored in the form of a list of dictionaries. So now these diarized segments are then passed as input to the speech emotion recognition system. So this system employs a dual encoder architecture, which is an acoustic encoder and a linguistic encoder. So in the acoustic encoder, we compute 30 Mel frequency Kapstar coefficients and 20 chromogram features. So Mel frequency Kapstar coefficients deal or they represent the spectral characteristics of a signal, whereas the chromogram features represent the pitch and harmonic information. So now the mean and variances of these features are then concatenated into a 80-dimensional acoustic feature vector. Now coming to the linguistic encoder, the linguistic encoder uses a transcription which is stored in the dictionary of the diarized segment. So it uses a transcription to generate a 100-dimensional word embedding. So now these word embeddings are generated using a word-to-vec model which we created and trained using the transcription of the customer and agents from our own call center data. So now the linguistic feature vector takes the mean of these 100-word embeddings and generates a final 100-dimensional linguistic vector. So now what happens is this linguistic vector and this acoustic vector is then concatenated into a 180-dimensional feature vector, which is then passed as input into the trained global model. So the speech emotion recognition model is based on a CNN and BiLSTM architecture. So this a network was run in a federated learning environment, which we simulated using TensorFlow federation. So the optimization algorithm we used for TFF was Fed average. So what happens is all the local models are trained in the 3 clients, which is the 3 call center data sets that we have. And we take the average of all the updates and train this model for to predict accurately. So now the result of this model is the emotion for each and every segment. So now this emotion gets appended as another key value pair in the list of dictionaries that we have. So each dictionary will now have the emotion as well in the list. So now this resulting list is then sent to the GUI, where in the GUI we will be able to display an analytics report so that the manager can get a visual aid of the speaker information, the emotional insights, as well as a few customer call center metrics. So now this report will kind of give the manager overview of the agents, and so he'll be able to assess both the effectiveness and the caliber of the agent client. Moving on, so the proposed model did have a consistent performance with a training accuracy of 88 and a testing accuracy of 82 for our data, for our call center data set. We also used other key performance indicators such as precision, recall, and F1 score. Now coming to the dashboard itself, our dashboard has 3 main components: the customer side analytics, agent side analytics, and the aggregated analytics. So we'll start with the customer side analytics. So the customer side analytics has a line graph to depict the emotional trend of the customer over the duration of the call. So along with that, there is also the transcript with the timing as well as a customer satisfaction score that we calculated. Similarly, for the agent side as well, there is a emotional trend of the agent's emotions during the call, along with the transcript and the time and a satisfaction score. Coming to the aggregated analytics, so this is an aggregated metric for all the calls. For the customer and agent side, it is per call where you have a drop down and you can select which call and you can view the trend. So this is for across all the calls. So there's a pie chart which illustrates the range of emotions shown by the agent over all the calls, as well as an overall satisfaction score, most commonly predicted emotions, and average call duration. So this kind of helps the manager to assess the strengths and weaknesses of the agents, and he can provide training or enhance customer satisfaction and so on. So coming to the future scope for our project, so advanced models like transformer-based architectures, recurrent neural network can be explored further in order to enhance the system's capability to kind of capture the temporal dependencies in audio signals. Then coming to diverse data sets. So again, we could use more extensive and diverse data sets in order to improve the model's generalization and resilience. And scalability and real-time processing can also be optimized by kind of refining our FL approach using TFF or also considering edge computing technologies.
Good afternoon to one and all present here. we submitted our paper to the International Conference on Nanotechnology, Renewable Materials Engineering and Environmental Engineering. The title of our paper is Monitoring the Effects of Non-Point Source Pollution on Marine Life. Our guide was Professor Sarita. I am Aradhana, and these are my teammates, Akshaya, Ananya, and Yashwant. And we all belong to the Department of Computer Science Engineering at ESCI. So non-point source pollution is actually a problem that is caused by various pollutants whose origin or source is unknown. So, and it pollutes groundwater as well as drinking water sources and also other water bodies. So possible pollutants could be nanoplastics, fertilizers, pesticides, animal and human waste, and so on. So the aim of our project is to analyze satellite images that we acquired from Landsat and to predict the sources, pollutants, and its effects on marine life. So as you can see the image, this is the region that we consider for our analysis. So we've taken a segment of the Ganga River that flows in Uttar Pradesh, and it flows through Allahabad, Mirzapur, and Raebareli. So we considered 30 years of data from like 1994 to 2023. In between, there's like a few years that were missing, so that is why. And each year of data is around 1 GB big because each image consists of several bands. Like you can obtain different types of information through the combination of like say 3, 4, or like any number of bands. And the aim of the project is also to like sort of create an awareness because research on this topic is very limited, and to like engage local communities and government agencies to raise awareness regarding this. So the related work, we went through a lot of papers for our literature survey, and these are some of the papers that we found interesting and related to our study. So the first paper is regarding land classification to predict the sources of pollution. So they're using 3 models, which is particle form optimization, leaf kernel, and extreme learning machine. They're using this algorithm in order to like classify the land covers and predict the sources. Then in the river Kali, they took into consideration the water quality indices using real-time data, which they acquired using like sensors, and they predicted that the water quality was very poor. Then in the there was a study conducted in Uttar Pradesh in the Ganga River, but here again they're using only water quality data in order to predict the quality of data. And then the fourth was regarding its effect on marine life. So it was a study conducted on zebrafish. So the genes of zebrafish has around 87% similarity to those of humans. So they figured that if they could figure out the toxicity or toxin levels in zebrafish, they could correlate it with the human body as well. So the summary of these papers, and like most of the papers that we read, was that physical sensors were used, and we found that that was expensive and also time consuming. And some models were restricted to that particular area. You couldn't extend it to other areas. So this is our architecture diagram or the flow of our project. So it starts off with extracting data from the USGS Earth Explorer. We extracted 30 years of data. Then we pre-processed the image. So pre-processing involves like removal of clouds, atmospheric correction, and also cropping to just get the river alone. Then it went to image classification, which was key in order to like figure out the different types of land cover. Then we did feature extraction. So a lot of features like vegetative indices, water quality indices, chlorophyll concentration, turbidity, and so on were extracted. Then we put it through time series analysis and figure out the trends and patterns. And we analyzed and predicted sources, pollutants, and impact on marine life. So in order to get sources, we used k-means. In order to get pollutants, we used linear regression and ARIMA. And in order to do marine life effect, we used LSTM, Ranoforest, and linear regression. So as you can see here, this is for predicting the sources. So on conducting k-means for the satellite images that we obtained from 1994 to 2023, we observed a cumulative change as follows that's displayed on the board. So you can see that there has been a positive increase in agricultural land, urban and residential land, and other land is basically industrial land, whereas there has been a decline in forest and natural land and wetlands. And pollution has also been increasing over these years. So we can say that with regard to our study of the Ganga River, the possible sources of pollution were agricultural land, urban land, and industrial land. That is the diagram of the land cover change over the 30 years. And we use ARIMA in order to predict the change for the year 2024. And as you can observe, wetlands and other lands are the only types of land that are observing a positive change. There's going to be a decline in natural vegetation, agricultural land, and urban land. But urban land is not, agricultural land is not that significant. So we did a correlation analysis. So we have two data sets. The first data set is satellite images that we have to extract. And the second data set is water quality indices that we obtained from CPCB. So what we're doing is we're correlating the water quality data with the satellite image. So the features extracted from the satellite image. So if you look at the right bottom corner, the chlorophyll A versus biochemical oxygen demand, it shows a positive correlation, which means that as one increases, the other increases as well. So if there's going to be an increase in chlorophyll A concentration, it could mean that there's an increase in algal blooms in the water body. So if there's an increase in algal blooms, there is going to be an increase in biochemical oxygen demand as well. And if you look above this graph, you have dissolved oxygen, which shows a negative correlation. Obviously, because if there's going to be an increase in oxygen demand, the dissolved oxygen is going to be lesser. So as chlorophyll increases, the dissolved oxygen decreases. Then we also did with respect to nitrate, and again positive correlation. And then we also did total suspended solids with respect to biochemical oxygen demand, and we got a positive correlation. Now, with respect to the pollutants, the pollutants that we analyzed were nitrogen and 5 heavy metals: copper, zinc, chromium, cadmium, and lead. So we analyzed and we predicted from 2022 to 2026, and these are our error metrics for the actual data versus, the historical data versus the predicted data. So we got a decent accuracy. The way we predicted nitrogen was we found the highest correlation, positive correlation of nitrogen with normalized difference water in lead. So based on that, we predicted it for the other years as well. And the heavy metal concentration was also predicted, and you can see the error metrics displayed in this area. Effects on marine life. So we used LSTM. We had data for only 2012 to 2021 for the water quality indices. So we used that data in order to predict for 2022 to 2026 using LSTM. And then as you can see, the validation scores and the accuracy rates are displayed for the values that we predicted. And dissolved oxygen was also analyzed in a similar way. For 5 years, we predicted based on the previous standard. Now, once that was done, we classified it into risk categories based on dissolved oxygen and biochemical oxygen demand. And for this, we used random forest. So the predicted risk levels for 2022 to 2026 for each data code. So for the river that we took into consideration, there were 7 areas where they had installed sensors and they were collecting the water quality data. So these were the risk levels that were predicted for these data codes. So in conclusion, we'd like to say that immediate monitoring and response to these regulatory measures, community engagement, education, long-term sustainability initiatives would help us combat with NPS pollution. Now, with regard to the future scope of our paper, we can correlate the heavy metal concentrations with cancer in human beings, particularly bladder cancer and gastrointestinal cancer, because these are the types of cancer that you get on consuming the water as such. That's it. Thank you.
Go to the mathematics, right? Model. Yes. Yes. For arena, right? How many years of the data is it?
30 years.
Data was yearly or monthly?
Yearly.
So arena also work in this, because arena is at least 50 years.
Ma'am, yes, we have an issue with regarding model frequency.
That is how accuracy accurate. So it's not well modeled, because for arena it should be 50 entries. Yes, you can use arena. If you have less entries, then you can use fuzzy arena, because fuzzy is used when you have a small data. Okay, noted. So if you will, as per this paper, if this paper will go under revision, definitely the reviewer will stop it. Okay, your methodology will not be considered as a novel. Because for ARIMA, there should be 50 years data. Yes, if the data was in monthly, then your entry should be at least 50. So you will get a best thing. And come to the graph. Prediction. Yes. Yes. You have done ARIMA, right? So have you tested data and trained data? Two sets you have done it? No. You have taken the data in a whole stretch and after that you have predicted future trends, right? It's totally wrong here. First, you have to bifurcate the data into two sets. First set will be the trained data set. Then based on the trained data set, you have to test the data. Okay. Suppose if you have a 30-year data, keep the 20 years data as a training set.
We have split the data into 70-30 ratio.
Yeah.
We have actually
Am I right,
trained
sir?
it.
Yeah, because we have, otherwise ARIMA will not work.
We have
We have
split it
split the
into.
data into trained.
Yes. So you have not mentioned anywhere you have tested the data and first trained the data as per the training model, you have tested some, and then after that you can claim that yes, our predicted data are accurate. Okay, and as per my knowledge, because this is my research work, that's what I'm telling you. So ARIMA will give you only 5 years prediction. Okay, and 50 years should be mandatory. Yes, you can use your small data set if you are using the fuzzy or neural network. And also, you have in previous literature already ARIMA has been done, right? So what is the fun to take the ARIMA here? You have to show your model efficiency, right? No doubt you are parallelly showing the concentration of this pollutant, right? But if the methodology will be new, the model will be new, then we can believe yes, the research is very trendy. Okay, you can do one thing. You can merge the models and you can do the hybrid modeling. Okay, first test from with one model, then mix the two models and add the neural networking or fuzzy. So you can use the ARIMA with clean. Yes, we were having the 30 years data, but we use fuzzy that reduces this. Understood? Otherwise, this paper is totally wrong. I'm declaring this wrong. Okay?
Good afternoon, everyone. My name is Isha, and I'm a student from Christ University. So, my topic is examining the mediating role of borderline personality traits in relationship between imposter syndrome and relationship structures. I'm from Department of Psychology, and my presentation is under the theme of social sciences and humanities. So first we can start with understanding what's imposter syndrome. So imposter syndrome is not exactly a clinical disorder, but it's a condition where an individual tends to experience that they like they're a fraud. So no matter how much talent they have, skills they have, or actual achievements they have, they still feel that they're not good enough and they are not worthy of all the appreciation that they get. Similarly, borderline personality disorder, it's a disorder according to DSM-5 of APA. So it's a personality disorder where people tend to experience difficulties in regulating emotions because they have the severe fear of abandonment and rejection from their loved ones. So, for instance, if you're in a relationship and you tend to have borderline personality traits, you're constantly very anxious and have difficulty regulating your emotions because you're constantly on the edge, feeling that your partner is going to abandon you at any moment. So, there's a previous research findings have suggested that there could be a link between imposter syndrome and borderline personality, as both the individuals tend to feel like they're not good enough and they tend to rely on the external sources for validation. And since both of them fear, both these conditions result in fear of rejection and abandonment in the individual, there's a high chance that the interpersonal relationships that they're part of will be unstable and mostly contribute to a lot of distress in their lives. So that's what my research is focusing on, to establish the relationship between imposter syndrome, borderline personality traits, and the relationship structures. So by relationship structures, I mean to say the two types of attachment styles. So how people relate to other individuals in the society is based on the attachment styles. So there is one particular attachment style known as anxious attachment style. So here individuals are overly dependent on their partners. It could be any kind of relationship, say it like with your mother, father, or your husband, spouse, or friendship, any kind of relationship. So the way you relate with them is that you're overly dependent on them. You're very scared that they're going to abandon you at any moment. So that classifies as the anxious attachment style. There's another attachment style known as avoidant attachment style. So here, in this attachment style also, you fear rejection. You fear that they're going to leave you at any moment. So you tend to stay away from them, and you tend to close off. You build a wall between you and the other person, hoping that they don't get to know you, so that they don't find a reason to abandon you. So this is what I mean by relationship structure. So we um, yeah, so coming to the methodology, so totally there were it's a quantitative study. It has a cross-sectional correlational design. So there were total 270 participants recruited from whom the data was collected using convenient sampling. But out of the 270 participants, 23 participants were excluded because they did not entirely fit the inclusion criteria. So in total, 247 participants were the data from 247 participants was analyzed for this research. So yeah, these were the tools used. The imposter phenomenon scale was developed in 1985 by the person who coined the term imposter syndrome, which was Clance. And then the second tool used was the McLean screening tool for borderline personality traits. So this particular tool helps to determine whether the particular a participant has the borderline personality traits or not. And the third tool used was relationship structure. So this tool helps to understand the attachment style of the participant, whether they are more inclined towards the anxious attachment style or the more towards the avoidant attachment style. Data was analyzed using the SPS software version 20, and the main tests done were the normality test, correlational analysis, and the mean. IRB board, the board was followed. So the first, coming to the socio-demographic details of the participants, majority of the participants in this study were females, and most of them were undergraduate students, as they were students. And the further analysis of the participants' descriptions revealed that most of them were in a relationship and considered their romantic partner or spouse as the most important person in their life. So normality test. So this test helps to determine whether the data is normally distributed or not to carry out further inferential statistics. So based on if you look at the table, we can see that only imposter syndrome, which is denoted by IPS, is normally distributed, or the rest of the variables are not normally distributed. But since the sample size of the entire so the sample size is 247, which is significantly high. It doesn't matter on which statistical analysis we used, whether parametric or non-parametric. So yeah, I've just proceeded the entire analysis with using parametric tests. So this is the main analysis of this research. This is the mediation table. So what we find out from this is that borderline personality traits tend to mediate the relationship between imposter syndrome and anxious relationship structure, which means that people who tend to have imposter syndrome will also tend to develop borderline personality traits, and because of combination of these two, they will have an anxious attachment relationship structure in their interpersonal relationships, causing a lot of distress. Also, we can see that the direct effect of the mediation analysis is significant. So that means that borderline personality traits has a partial mediating role to play and not complete. This is the second mediation analysis for understanding the mediating role of borderline personality traits between imposter syndrome and avoidant relationship structures. So similar findings have come, which says that borderline personality traits do mediate the relationship between imposter syndrome and avoidant relationship structure. But a key difference here is that the direct effect found was insignificant, which suggests that there's complete mediation happening in this particular model. So, yeah, this is the interpretation of the mediation analysis. So what this means is that people who grow up with imposter syndrome usually come from a background of a lot of childhood maltreatment, which means like some form of abuse or invalidating environment, or maybe something as simple as neglect. So when they when they grow up in such an invalidating and abusive atmosphere, there's a high chance that they develop borderline personality traits. Now, when I mean borderline personality traits, not necessarily that they have the disorder, but they have like characteristics similar to that personality. And this becomes very difficult for them to regulate their emotions and hence have stable relationships. That's exactly why a lot of interpersonal relationship issues come because of this invalidating atmosphere that they're surrounded by and the traits that they inherit. So my study tends to have a lot of theoretical implications because these two variables, the imposter syndrome and borderline personality traits, have not been explored theoretically. Hence, it contributes to the literature. Second, it has a lot of therapeutic implications because, as we know, borderline personality traits happens to be a clinical disorder, and understanding the background of it and how it can be traced to its causes as well as consequences, it helps to develop a lot of early interventions. Third, I think it has like significant social implications because borderline personality disorder happens to be one of the most misdiagnosed disorders simply because of all the stigma and stereotype that surrounds it. So most often in the patriarchal society, you will see a lot of women get diagnosed with borderline personality disorder only, especially when they're expressing their needs. Because of patriarchy, women are seen as more emotional, more vocal about their needs, whereas men are seen as someone who are more towards the practical side of the whole relationship aspect. So every time women express their needs, or every time women are more vocal about their emotions, they are labeled as borderline personality. To put it simply, they're labeled as someone who are very crazy, clingy, or needy. So such terms tend to stigmatize borderline personality a lot because they don't understand the depth and gravity and the actual struggle people face in regulating emotions. So with this study, by telling them that it actually stemming from childhood maltreatment and childhood abuse, it helps to foster empathy among the masses towards borderline personality disorder. It helps to destigmatize the disorder, and it also helps in psychoeducating the public about the consequences of borderline personality disorder. So these are the implications. A future study actually can use a longitudinal design using the experimental approach to establish the cause and effect. So there is no particular study which says that imposter syndrome causes borderline personality traits. There's no such study done, and so it's very difficult to pinpoint what exactly causes borderline personality. So maybe an experimental design in the future could help us understand what's the cause and effect of this whole dynamic. Second, since I mentioned interpersonal relationships are usually unstable because of the whole anxious and avoidant attachment style, maybe future research can also start focusing on specific types of relationships, whether is it like a live-in relationship, is it a marital relationship, or is it just a romantic relationship. Such various types of relationships exploration can give us more in-depth knowledge about this complete phenomenon. One limitation about this particular research study is the social desirability effect. So now, as I mentioned, the tools of this study focused on gaining knowledge about the participants' way of attaching with people, whether they are more anxious or whether more avoidant, and about borderline personality traits, right? How difficult they find regulating emotions and things like that. So there were few sensitive questions within the tools. So now there is a high chance that the participant would have, kind of faked the answers, or maybe not been completely honest about it because they wanted to appear more socially desirable to the researcher. So that could be one effect that could have resulted in slightly distorted results. Yeah, that's it. So this is the end of my presentation. I would like to thank all of you for listening to me.